All right, now we're going to work the other side of the paper, which is problems 7 through 12. On number 7, my highest power is cubed. So I'm going to push everything to one side and decide how many terms I have to solve this problem. I want to keep my leading coefficient positive. So I'm going to leave this as 2x cubed. X squareds are coming next, so minus 6x squared. X's need to come next, so that's minus 5x because I'm moving it, and this 15 is going to stay positive because it was already on the left-hand side to begin with. All right, so I got 4 terms leading off of the next cube, so grouping should be my first option that I'm going to try to solve this problem with. All right, so looking at this problem, first 2 terms, what can I take out? 2x squared. So when I take a 2x squared out, I'm left with x minus 3. If grouping really works, I should have an x minus 3 when I take something out of these 2. All right, these 2 terms right here leads off with a negative, so I need to take a negative out. And what goes into 5 and 15? 5. So when I take that, I'm left with x, and 15 divided by negative 5, there's that negative 3 that I needed in order to group this problem. So grouping works. So x minus 3 is what's in common. So x minus 3 is going to pull in front, and then 2x squared minus 5 is what's left over, so that's going to become my other factor for grouping. Now I got to take each one of these and set these equal to 0. So here's my first one. X minus 3 is set equal to 0. I add 3, and x equals 3 should be that solution. To solve this one, 2x squared minus 5 equals 0. First thing I'm going to do is add 5, so 2x squared equals 5. Next thing I'm going to do is divide by 2, so x squared equals 5 over 2. And last thing I need to do is take the square root. When I take the square root, I get 2 solutions, so x equals plus or minus. Right now, the square root of 5, I can't simplify it, so that's just square root of 5. Square root of 2, I can't simplify that either. So I can just leave this as plus or minus the square root of 5 over 2. So my solutions, remember I need 3 solutions. 1, 2, 3. So I've got 3 and plus or minus the square root of 5 over 2. Number 7. All right, then we're moving on to number 8. On number 8, I'm leading off of the negative 1/2 right here. When I scoot this 2 over, I've got 3 terms. So my options are factoring or quadratic formula. Either one of those, I need to make this equal to 0. So I'm going to move my 2 over. When I subtract 2, 6 minus 2 gives me 4. So this is negative 1/2 x squared minus 6x plus 4 equals 0. Now checking the discriminant. The discriminant is going to tell me what direction I need to go in order to solve this problem. So negative 6 squared minus 4 times, be careful here because A is negative 1/2, times C, which in this problem is positive 4. Now when I solve this, I get out 44. 44 is not a perfect square, so I need to solve this by the quadratic formula. All right, so quadratic formula, negative b. So this is 6 plus or minus the square root of what I just got, 44, all over 2 times a. Now be careful right here. 2 times negative 1/2. A positive times a negative is a negative, and 2 times negative 1/2 is just going to give me out positive 1 right there. Okay, so 2 times negative 1/2 gives me out negative 1. Now, next thing I need to do is try to break this down. 44 is 4 times 11. 4 is my perfect square, so that's 2 on the square root of 11. So 6 plus or minus 2, oh, my 2 is out in front, on the square root of 11, all over negative 1. Now, to solve this problem, all I need to do is give this negative 1 to both of these things, because I don't really like a 1 or a negative 1 being the bottom, or negative at that point. All right, so 6 divided by negative 1 is negative 6. Now, positive 2 divided by negative 1 is negative 2. Negative 2 divided by negative 1 is positive 2. So really my signs just stay right here, plus or minus 2 on the square root of 11. Now, going back to my original problem, on number 8, highest power is 2, and I got out 2 solutions, negative 6 plus 2 on the square root of 11, and negative 6 minus 2 on the square root of 11. So I'm done. All right, then I get to number 9. On number 9, first thing I notice on the left side is I got 2 terms. If I take this 28, it's going to add to that negative 52, so I still got 2 terms. So the best way to solve something with 2 terms is to solve this thing straight out. So to solve this problem straight out, first thing I'm going to do is add 52 to both sides. So 28 and 52. 28 plus 52 is going to give me 80. So this is 4x squared equals 80. Next thing I do is get rid of the 4. To get rid of the 4, I'm going to divide by 4. So x squared equals 80 divided by 4 gives me out 20. Last step, to get rid of something squared, I need to take the square root. When I take the square root, I get 2 solutions, positive and negative. So this is x equals plus or minus. Now I got to break down 20. 20 is 4 times 5. So look at it looking like this. The square root of 4 gives me 2 on the square root of 5. So this is plus or minus 2 on the square root of 5. And I got 2 solutions out, and that's exactly what I needed. So there's number 9. All right, next one. Going to number 10. Number 10, I've got 3 terms. So I've either got factor or the quadratic formula to solve number 10. So it's already set equal to 0, so I can take this problem and check for the discriminant. Negative 13 squared minus 4 times 4 times 3. And that gives me out 121. Now, 121 happens to be a perfect square, which means I can factor this or use the quadratic formula. I'll go quadratic formula first, and then I'll take it into factoring. So to solve this problem, since I've already got b squared minus 4ac out, quadratic formula is just around the corner. So negative 13, opposite of it is 13, plus or minus what I just got out, square root of 121, all over 2 times 8. 2 times 4 gives me 8. All right, so this is 13 plus or minus the square root of 121 is 11 all over 8. Now right here I need 2 distinct solutions. So I'm going to take 13, I'm going to add 11, which gives me 24, and then 24 divided by 8 gives me 3. So 3 is one solution. All right, then I'm going to take 13 and subtract 11. That's going to give me 2, and then 2 divided by 8 reduces into 1/4. So here's my 2 solutions, and that's exactly what I needed, 2 solutions. Now to factor this problem. When I come over here and factor, you can write these terms out again, 4x and 4x, using the bubble method. And then I'm going to take 4 and 3 and multiply those 2 things together. 4 times 3 gives me 12. So I'm looking for 2 numbers that multiply to give me a positive 12, but add to give me a negative 13. That's 12 and 1, but both of them need to be negative. So this is minus 12 and minus 1. All right, then I'll look at this first one, and what can I take out? I can divide everything by 4. When I divide everything by 4, that becomes x minus 3. This other one stays, 4x minus 1. So to solve this, I take x minus 3, set it equal to 0, add 3, x equals 3. This one, 4x minus 1 equals 0. I'm going to add 1, so 4x equals 1, and then divide by 4, so 1/4. Same 2 solutions as if I would have done it with the quadratic formula. All right, last 2 problems we got are 11 and 12. 11 starts off with x cubed. Number 12 has x to the 4th in my problem. So looking at number 11 first. First thing I look for terms, leading off with x cubed, is does grouping work? So out of the first 2 terms, I'm going to take an x squared out. If I take an x squared, I'm left with 3x plus 1. These 2 terms, I can take a 2 out. So if I take a 2 out, I've got 3x plus 4. So right here, grouping does not work since both of these do not match. So grouping is out of the question. So if grouping doesn't work, what do I have to go to next? P over Q's. All right, it's set equal to 0. So I'm good to start with right there. So I got PQ, P over Q. So P, I'm looking at this last number, which is 8. I need to find what are my factors for 8. So that's 1, 2, 4, and 8. For Q, I look at my first number, which is 3. So that's 1 and 3. So now I find all my P over Q's like we did the other day. So 1, 2, 4, and 8 all get divided by 1 and gives me 1, 2, 4, and 8 back. Next thing I do is I take 1, 2, 4, and 8 and divide by 3. So the first one is 1/3. I'll put it right up under here. The next one is 2/3. The next one is 4/3. And the last one is 8/3. So I've got 8 possibilities, but remember it's plus or minus. I really have 16 possibilities that I have to plug in to see which one of these is going to come out to give me a 0 for this problem. All right, so let me zoom out here so you can see what's happening to this problem on number 11. All right, y equals, typing in my original function right here. So 3x to the 3rd plus x squared plus 6x plus 8. And I type that into y equals. Now I'm going to type all 16 of these possibilities in to see which one comes out to give me a 0. So second graph gets me to my table, and I'm starting to type. Now remember, my table second window is set up in ask. So this allows me to type all these numbers in instead of scrolling up and down and finding these numbers. So go back to my table, second graph, and I'm typing my numbers in. 1 does not work. -1 does work. So I'll come down here, write 0, and put -1. Now, if I can get 3 of them out, then I'm done. If I can't, then I got to go into synthetic division. All right, so 2 doesn't work, -2 doesn't work. 4, no. -4, no. 8 does not work. -8 does not work. So now my fractions. 1/3 does not work. -1/3 does not work. 2/3 is no. -2/3 is also a no. Next one I got, this should be 4/3, y'all, not 4/8. Next one I've got is 4/3, doesn't work. -4/3 also does not work. And then the last I got is 8/3, does not work, and -8/3 does not work. This should be an 8/3 right here. All right, so the only one that I got a solution out for was -1. So synthetic division is next. So -1, and I'm looking at my coefficients right here. 3, 1, 6, and 8. Dropping down my 3, and then I start multiplying. -1 times 3 gives me -3, so -3 goes up under here, and now I add. 1 minus 3 gives me -2. Now I multiply. -1 times 2 is +2, and now I add. 6 plus 2 gives me 8. Now I multiply. -1 times 8 is -8, and I add and get 0. If this was truly a 0, my remainder should come out to be 0. So this is what I've got. I started with x cubed, and I'm x squared. So 3x squared minus 2x plus 8 equals 0. And now we're back to quadratic, which we know how to solve. So I can solve this by factoring or quadratic formula. So let's check the discriminant to see which direction it's going to tell me to go in. So I've got -2 squared minus 4 times 3 times 8, and that gives me out -92. Now, -92 is a negative number, which tells me I'm going to get out imaginary, and I'm going to see if I can't break 92 down to get my solution. All right, so -b2 plus or minus the square root of -92 all over 2 times a, 2 times 3 gives me 6. All right, 92 ends in an even number. So I'm going to take 92 divided by 2. That's going to give me 46. And so from here, this is also even, so I can divide by another 2. So if I divide it by 2 and 2, 2 times 2 gives me 4. So 92 can go into 4. So this thing breaks down to 4 times 23, which is 2 on the square root of 23. So since it's negative, though, this is going to be 2 plus or minus 2i on the square root of 23, all over 6. All right, next thing I've got to worry about is how can I simplify this thing? 2, 2, and 6, I take a 2 out. So this is 1 plus or minus I on the square root of 23, all over, don't forget to divide this by 2, which gives me out 3. Now this is 2 solutions. I need 3 solutions. Other solution comes from right here where I found my 0. So -1 and 1 plus I on the square root of 23 over 3 are my 3 solutions to this problem. All right, last one. If I'm looking at number 12 to solve this problem, this is a fourth. Grouping's not going to work here, so I'm going straight to solve for my P over Q's. All right, so looking at P, 24. A lot of numbers multiply to give me 24. 1, 2, 3, 4, 6. Now I'm looking backwards here. 4 times 6, 8 times 3, so there's 8. 12 times 2, and then 1 times 24. All right, going for my Q's. 4, I've got 1, 2, and 4. Now I'm going for my P over Q's. To solve for my P over Q's, I'm going to take all these P's and divide by all of my Q's. So 1 first. So I get the same numbers back. So those same integers from the beginning, I'm going to write over. Yes, make sure you write them over. All right, next thing, I'm going to take all these and divide by 2. So one that comes out is 1/2. Next one is 2 over 2, which is just 1. 3 over 2 is my next one. 4 over 2 is 2, 6 over 2 is 3, 8 over 2 is 4, already got it, 12 over 2 is 6, got it, 24 over 2 is 12, already got it. So now I'm working with 4s. First thing I've got is 1/4. Make sure you put plus or minus. Then I've got 2/4, which is 1/2. 3/4 I don't have on there. 4/4 is 1, 6/4 reduced to 3 over 2, 8/4 is 2, 12/4 is 3, already got it, 24/4 is 6, already got all those. All right, my next step is to take all of these rationals and plug them into my original function to see if any of these things work. All right, so back to y equals 4x to the 4th minus 17x to the 3rd minus 3x squared plus 8x minus 24. All right, going to my table, typing all these in. 1, -1 until I get a solution out. 2, -2, 3, -3, 4, -4, 6, -6, 8, -8, 12, -12, 24, -24. So none of those integers worked at the top, those whole ones. All right, now my fractions. 1/2, -1/2, 3/2, -3/2. Typed it in backwards. 1/4, -1/4, 3/4, and -3/4. All right, so nothing worked right here. So this right here, to solve this problem for my zeros, I'm going to write no rational solution, which probably means my solutions to this problem are all going to be imaginary answers. All right, so there's your review. You got your quiz tomorrow on this same similar solving quadratic and polynomial functions.